In Christopher Chabris and Daniel Simon's famous gorilla experiment, participants watching a basketball passing video and counting passes missed a person in a gorilla suit walking through the scene and pounding its chest. Half of all viewers failed to notice the gorilla. This is inattentional blindness. We do not see what we do not look for. Attention is a spotlight, and everything outside its beam is effectively invisible. Selective attention is the capacity to focus on specific sensory information while filtering out other information that competes for processing. Because the brain cannot fully process all incoming sensory data simultaneously, attention acts as a gatekeeper, prioritizing relevant information and suppressing irrelevant signals. The cocktail party effect is the classic demonstration. You can follow one conversation in a noisy room while filtering out others, yet instantly notice your name mentioned across the room, demonstrating that filtered information is still being monitored at some level, just not fully processed. Inattentional blindness is the failure to perceive a clearly visible stimulus when attention is fully engaged with a competing task. The gorilla study is the most famous example, but inattentional blindness has real-world consequences. Pilots focused on instrument readings have failed to notice other aircraft. Drivers attending to conversations have failed to see pedestrians. Radiologists focused on one lesion have missed a second one in a different location. The implication is disturbing. The experience of conscious visual awareness does not tell you that you are actually seeing everything in front of you. Change blindness is the surprising difficulty in detecting changes between two scenes, changes that are obvious once pointed out but unnoticed when attention was elsewhere. In classic demonstrations, a person asking for directions is briefly obscured by workers carrying a door, and during that moment the experimenter is replaced by a different person. Most participants notice nothing. Change blindness and inattentional blindness together reveal that conscious visual experience is far more sparse and constructed than it feels. The rich visual world we seem to experience is largely an illusion. A perceptual set is a mental predisposition to perceive a stimulus in a particular way, shaped by expectations, context, prior experience, and motivation. Context creates perceptual sets. The same drawing looks like a rabbit or a duck depending on which interpretation you were primed with. The same person described as cold or warm before a brief meeting is rated very differently afterward. Radiologists who are told a scan is normal before examining it miss more pathology than those given no prior expectation. Perceptual sets can facilitate efficient perception or create systematic errors. Top-down processing refers to the influence of prior knowledge, expectations, context, and goals on the interpretation of sensory input. Rather than perception flowing only from sensory data upward to analysis, higher cognitive processes flow downward to shape what we perceive. Reading is a top-down process. You can read sentences with misplaced letters because the context provides strong expectations about what words should appear. A blurry face becomes unambiguous when you know who it is. Native speakers of a language hear ambiguous phonemes as belonging to words in their language. Foreign speakers do not, because they lack the top-down priors. Bottom-up processing refers to perception that is driven purely by the features of the incoming sensory stimulus, starting from the raw data and building up to recognition without prior expectations. When you see a completely unfamiliar script or object, you cannot apply strong top-down expectations, so perception is dominated by bottom-up feature detection. Bottom-up processing is also dominant in early sensory processing stages, where features like edges, colors, and orientations are extracted before any recognition occurs. Effective perception typically integrates both processing directions simultaneously. Research across cultures has demonstrated that perception is not culturally universal in the way that early psychologists assumed. The Muller-Lyer illusion is weaker in people from cultures with circular or organic architectural environments compared to those from carpentered environments with right angles and rectangular spaces. Cultures that do not have exposure to photographs initially interpret them differently than Westerners. Perceptual habits formed through cultural experience shape attention, object recognition, and spatial reasoning in ways that generalize across tasks. Richard Nisbet's cross-cultural research has documented a systematic difference in perceptual style between East Asian and Western samples. When shown scenes with a focal object in a background, American participants tend to focus on the focal object and remember it well, but forget background details. Japanese participants attend more to the relationships between the focal object and its background, showing better memory for context. This holistic versus analytic perceptual style generalizes across tasks and appears to reflect cultural differences in how attention is guided. Perception is active, constructive, and shaped by everything that has gone into making you. Your evolutionary heritage, your culture, your prior experiences, and your current expectations and goals. The world as you perceive it is not the world as it is, but the world as your brain has learned to model it. Understanding this is not disorienting, it is empowering. It means that what you perceive is modifiable, and that being wrong can be corrected.